Start recording. $11.21. All right. How do I lock this door? There we go. Grab our victim. 2015 13-inch MacBook Air. Liquid damage. Once we learn this is a liquid damage machine, the first thing we're going to do is perform a visual inspection of the inside of the machine itself. We are not going to power this on because we could cause more damage. First step is we will take the bottom screws out. I apologize for any static. I haven't shaved in a while. I have a pretty thick beard, and when my microphone rubs on my face, it causes a bit of a static noise. I tried to bend it away so you aren't getting static. So once again, I apologize if there is any static in the audio. Go ahead and remove the bottom cover from this machine and inspect. Alright, so far we do see that we're going to go ahead and unplug the battery as well right away. We do see upon our first inspection, the liquid damage indicator is tripped there, and you can see kind of a haze around some of these parts. So that, as you can see, kind of a shiny area on the board, and also underneath the LCD cable. Focus. Yep, you can see that's nice and red, so there was liquid contact there. We'll go ahead and go to microscope camera and see if we can find anything really damaged on the LCD cable. We'll start there. Whoops. Of course, I put my mouse right next to my work area, and it doesn't look like we have any damaged pins on the LCD cable, so that's good. So our LCD is intact. This area actually looks pretty good. There's a minor cloud of what looked like liquid around here, but nothing's corroded. Nothing on this side looks bad, so we'll go ahead and try to power the board on. Well, no, we're gonna pull the board first. We'll go ahead and pull the board before we power it on. I want to make sure we're extra safe. Don't want to actually power the board on when there's liquid on it, because you could short out more stuff, cause more damage, and throw screws everywhere. That's not really what will happen. That's just what happened to me. Because I'm trying to be I'm trying to do this in haste, and go ahead and disconnect all of our cables. We got our touchpad cable, our keyboard backlight, our right speaker. Go ahead and unplug our antennas as well. We will unplug the DC board and the camera. And that should be it for the cables. We'll go ahead and remove all the screws. Sorry, I know I'm kind of on the edge of the table here. We'll move it a little closer there. Apologize for the subpar quality of the overhead camera. It's really far away from my bench. I have a new stand for the overhead camera that's going to bring it down to about just above my microscope camera, so you'll be able to get a closer view. I just haven't had the time. We've been super busy, so I haven't had time to install it. But being busy is good, right? Alright, got all of our screws removed. I think there's one more under here. Oh, it's missing. Okay. So we got one screw missing, the one that goes to the end of the CPU heatsink down here. There's this little tiny screw that sits underneath the Wi-Fi that's missing, so don't need to remove that. Excuse me for just a minute. Alright. Get our... Let's see what we can find here. Go ahead and focus up on our board. This is our PP3V42 area. Looks like a salt crystal or something. U1950 looks okay. This diode looks okay. Everything looks okay there. Even though it's tripped, it doesn't look bad. I don't see anything corroded or horrible looking. This is our backlight circuit area. Our backlight fuse. Looks okay. Yeah, so it looks okay. All of our critical areas look okay. I know, let's measure CPU V-core resistance to ground real quick to make sure that the CPU is not shorted to ground and wasting our time. I like to do this test because there are a couple boards that looked immaculate that I got in and the computer wouldn't turn on, and of course as soon as I measure CPU V-core to ground it's like 0.1 ohm, so you know it's kind of a lost cause. We're at 18, so on this board it should be 12 to 20, so 18, it's good. Alright, let's look at all this, the backside now. There's our backlight driver, looks pretty good. Evidence of some, I don't know if that's dry, is that dry? Yeah, it's dry. I mean, it might be safe to power this board on if we don't notice anything. There's our ISL, looks okay. It does look like this board has been worked on That's pretty shiny right there. I don't know if this board's been worked on before. It's possible. Look at our SMC. SMC's looking a little meh. Let me see if I can zoom out a little more, or come out a little more. It's not very bright, but that's okay. I'd rather have it a little bit dim than super exposed. Yep, that looks okay. U7501. So our TPS 51980 looks okay. U1900 looks okay. Our BIOS looks okay. So it's just some general shininess, weirdness to it. There's our TBS 51916. Looks alright. Ah. Yes. Okay. There we go. U1950. This is part of the Allsys power good. That does not look okay. That looks horrible. That is definitely going to be a problem. As you can see, and I've worked on tons of these boards, so I know that there is a component missing and a trace. So right here should be a capacitor to ground. Or, I'm sorry, this is, yeah. This is, I think, is that PP3V42 going into this chip? Let's open up Flex board view and see. We'll go to Flex BB Cam. File open. This is a 820000165 logic board. What do you mean there's an error? Alright, let's go. Let's zoom over to our U1950 area. We're going to do a search on the PDF. Sorry, I can't show you the PDF. Yep, pin 8 is the input for this. This comes from PP3V42 G3 hot. And then C1950 is a bypass cap. Oh, sorry. This bypass cap that goes to ground here on this side. And PP3V42 powers U1950. So the problem is, A, we're missing our bypass cap, and this connection, this trace that goes from PP3V42 to this chip is missing. On top of that, this chip is looks a little corroded, so we're gonna have to pull it off and see if we can't repair that. So right away, we're going to turn on our fume extractor. Get our hot air station, see if we can remove that and see if it'll repair it. Once we pull this chip off, I'm going to go ahead and see if we have any other corroded areas. We'll go ahead and fix this area up. Oh wait, you know what? Yeah, no. We know this isn't powering on. I'm not going to even try it. Well, I guess, you know what we could do? Just for science, let's try to power it on since let's look around and try to power it on since we have no, what it seems to be no active corrosion going on. Let me see if I can zoom this. I apologize for the noise, I just figured we'd look around some more. PP3V3 sus area looks okay. See if we got any other spots. Kind of getting ahead of myself a little bit. No. Yeah, I don't see anything else. Anything else corroded, so I think that's gonna go ahead. That's gonna be our problem. Let's go to the overhead cam real quick. We're gonna put in our test TCN board. Whoops. We're gonna make, just so we can make a note of what the current draw is. I'm assuming it's gonna be around 100 milliamps possibly, with U1950 being out of commission. Excuse me. Sorry about that. I'm going to have to edit that out. Alright, let's set our power supply to 18.5 volts. Power it on. We have a MagSafe light, and we're drawing 30 milliamps. So there's our frame of reference. 30 milliamps at 18.5 volts. We have a MagSafe light, and I'm sure if we flip the board over real quick and we put our multimeter on voltage and we take our microscope camera and we probe that area where U1950 is, we can probably see, measure if 3V42 is. Let's power it off real quick. What I'm going to do is scrape it, this trace right here where PP3V42 goes into the chip. I believe it comes in from here. This is our supply. We're going to have to solder a wire here anyway. Sorry, I apologize. Getting ahead of myself a little bit on the removal of the chip. Doing some digging, pun intended. What we're probably going to do is, yeah, we'll run a wire up through here and just piggyback our capacitor on it. Oh, there's still some trace left. That's a good sign. Alright. Let's measure, shall we? Okay, turning the board back on. We're now at 164 milliamps. And we have fan spin. Weird. So I would expect, with Allsys Power Good missing, we'd be at about 100 milliamps or so, 150. So that is what I would consider normal current for missing Allsys Power Good. Yep, we have PP3V42. So that is our issue. So we have the PP3V42 supply to the chip, but it's not making it there because that trace is broken. Alright, now we'll go ahead and do it. A little bit unconventional. We just kind of dove into, we're going to remove that chip. Now we'll turn our extractor back on, make some noise. We'll repair this area and see if we get our proper 500 milliamp current draw. We're going to go ahead and replace this resistor too. Yeah, it looks okay. It's stuck to the board, but in the long term, with those gray end caps, we don't trust it. So we'll remove him from the board. Tidy up this area, and hopefully we'll have a working logic board. I don't like the looks of those traces right now, but let's not give up. Let's not abandon all hope just yet. Those traces do not look good. Or pads, sorry. Not traces. Alright, let's grab some Amtech flux. That's the pad that concerns me the most. Is this one goes to the PMSOP good. We gotta have that one. This is not connected, so it's not super imperative that we replace it, but go ahead and do some gentle scraping here. We just want to reveal our pads. If they're left. We are going to mask this probably. Okay. Great, we do have pads still. Wonderful. So we're going to take some wick and just kind of gently remove all that solder we put on there. Just to kind of clean that area up, make those pads shiny, pick up any residual dirt and nastiness. Wow, wonderful. We got some good looking pads still. Oh, very good. Like I said, this doesn't matter. It's not connected, so that isn't important. This is important, and this is important. All right. Good, 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 good. Some IPA. Yeah, those pads look pretty good. Definitely still serviceable. They're still attached. So I'm confident we can make this look good. Okay, our next order of business. We are going to now... Once again, I apologize that the screen is so dark, but you saw how much reflection that flux gave right now. I mean, imagine if I had the auto exposure on and it brightened it up, you would be able to see anything. Right now we're going to run a little solder mask in between these pads and these pads, because we don't want a big blob of solder there. So we're going to tidy that up with a little solder mask. And we'll just go ahead and run a little trace wire here, and then we'll just piggyback our bypass cap over here somewhere and put a nice blob of solder on there. Alright, so we're going to need our X-Acto knife to apply the solder mask. We're going to get our UV light. We're going to apply way too much solder mask. And that's okay, because what we'll do is we'll cure that, and then we'll just scrape off what we don't need. Here comes the light, so watch your eyes. See if that cured it all. It looks translucent, so that may not have any curing stuff in it. That's right, that doesn't really matter because there's nothing going there anyway. No resistor. It'll be a good placeholder for now. Now what we'll do, apply a little flux and some solder to all the areas that we need it on. Just a little bit. We don't need a ton. We're going to have to clean that solder pad up there. We should probably mask that as well. Do some gentle scraping of that. Oops. Applying the solder everywhere else except for where it needs to go. Okay. While we clean that up, we'll go ahead and absorb all that solder again. We'll do the same thing. We'll mask that off so we get a nice, just a nice little solder pad so we don't have a big giant blob of solder all over. Make it look a little decent. These are all extra steps. You don't necessarily have to do this to get the board to a working condition. This is just more preference on my part to make it look good, or better I should say. Oops, I got too much. Way too much solder mask. This stuff's pretty tricky to apply. Can be. Doesn't always want to cooperate. It is a liquid, of course. Alright, we'll cure that too. That way when we saw our capacitor, or solder our capacitor on there, we don't have a giant blob of solder going all over the place. We just want it on the pad where it was originally located. Okay, should be sufficient. Yep, it's nice and dry. All right. The hardest part of this is probably going to be doing the wire. Doing the wire from here to here because it's so close to the pad. We're going to solder the U1950 first, I'm thinking, because that's always the biggest pain, and then putting the wire on after should be straightforward. tip is oxidized a little bit. Some solder there. Some solder on all our pads for our U1950. Alright. See, we're good to go now. We'll get our parts that we need. Go ahead and get that stuff soldered on. Clean her up and give her a test. Find our A1466 boards here. All stuck together. Okay. And there's our 3 parts we need. Alright, I'm gonna go silent for a minute because I'm gonna go ahead and take these parts off. Seem to have lost my resistor. Not a problem. We'll just grab another donor board. touch up these joints here. Alright, so that's done. Once again, I apologize that it's so dark. Like I said, if I up the exposure, it's going to wash out everything. Probably need a little more solder for that. Gonna burn through the enamel coating on the wire. Right. Sorry, all over the place here. That's what I wanted. Just wanted a little extra solder on this. All right, that's good. Nice and solid. We'll go ahead and heat it up a little bit and then clean it up with some IPA. Let's heat it up just a tiny bit. Alright. Get all those little fibers off there. I think I'm going to put a little more solder mask on our wire, on all of our traces, just to fortify our repair. Some there probably. A little extra there. Watch your eyes. That should do it. Everything all nice and solid. Yep. Go ahead and give me just a second here. I'll be right back. Go to overhead camera real quick. I'm gonna try to take a picture of this if I can. Or maybe not. I'll just take a still out of the video. See if I can zoom in. I'm going to turn this fume extractor off. We don't need that anymore. So as you can see, we had to run a wire from PP3V42 over to pin 8. It's not the prettiest thing in the world, but it's solid. And it will work. Yeah, it's not a Picasso, but, or it is kind of. Anyway. Alright, let's go to overhead. I'm not even going to plug it into the power supply and try to turn it on. We're gonna we're going to run with our ego a little bit, and we're going to put it back in the chassis and see if the computer actually turns on to a blinking question mark folder. Because we think we did a good repair, and this board is going to turn on. We are confident that we successfully fixed this board. Mainly I'm doing this because we already had a fan spin, but since ALPSys power grid is not present, we're not getting 500 milliamps. So we're just going to go straight to the flashing question mark test. T5. Just throw in one logic board screw. Maybe two. We're not going to plug in anything else. Got our speaker plugged in. Go ahead and plug this in. We're just going to plug everything in later. Let's plug the battery in. We'll use the battery. See if the battery has a charge. I don't want to cheat at all. I want to be surprised along with you guys. Alright, I'm going to push the power button. Better yet, watch. We'll do this. Power button. We got nothing. Is the battery dead? Batteries could be dead. Alright. Maybe we didn't fix it. Charger. Power on the power supply. $500 milliamps, and I heard a chime just now. I don't know if you heard it. We'll kind of angle this up so we can see. Oh, can't really see anything good there. Did I just attach a screw onto the back? Yep. We'll have to find that screw. There's the screw. And as you can see, we indeed have a flashing question mark folder, which means this logic board has been repaired. Although the current, the current's at 800 milliamps, which suggests that it's the battery might be at 100%. I don't know. You know what? We're going to power it off and turn it on without the battery and make sure it stays at 500 milliamps. Could have an issue with the battery as well. Why are you sitting at 109 milliamps even though I turned you off? Unplug the battery. I think there's something wrong with my power supply. Plug it back in. With no battery. Let's see. Yep, we're sitting at 500 milliamps, so that's a good sign. Chime. wonder if I damaged my power supply, because it's saying 700 milliamps, which seems a little high, but I mean the board's turning. Is got a flashing question mark folder. Let's try our other power supply here. Oh wait, that one only goes to 16 volts, so that's not going to be helpful to us. You know what? We're going to boot to an external really quick. Let's boot to an external and just make sure there's nothing goofy going on. Make sure the board actually is working. Got the battery plugged in. You know what, we'll go ahead and it'll pick its own operating system. I've got my external SSD with multiple Mac OSs, so it'll probably select the right one on its own. Should boot up, we'll check. Let it go and see. You know what? Let's do a PRAM reset. This seems to be taking forever. We'll do a couple PRAM resets. See if that speeds it up at all. Now, Option Command PR. The chime should get louder. Oh yeah, that was significantly louder. We'll do one more. Maybe two. Alright, so we did a PRAM reset. We'll see if that helps at all. Well, the current just jumped up higher, so that means that's kind of a good sign. Probably could have something weird going on. Yeah, see, it booted much faster this time. So, PRAM reset probably helped out a little bit. Saw the Apple logo a lot quicker. The CPU is awfully warm. Wondering if we're having an issue with another component. 800 milliamps seems kind of high. Normally these boards are about 500 when they're booting up. But I mean, it's on. It's taking a minute to, a little bit to load here. Uh-oh, is my battery going? I think my battery is dying in my headset. The light's blinking. Just a minute. Still working? Yeah, I can see the sound meter working. Or moving. Let's see. Coconut battery. This computer does just seem to be running a little slow. Let's see if we got sensor problems. I don't like that light blinking. Cycle count 170. Design capacity 90.1%. So the battery is good, it's just dead. Let's go to hardware monitor and see if we could find any sensors that are acting up. Nope. All the sensors that were reading temperatures are not high. Our 12 volt rail though is showing 6.5 volts. That's kind of weird. We'll go ahead and test our keyboard. Make sure our keyboard's working. Can't hit F11 because that closes the screen or the window. Yeah, keyboard works. It seems to be running okay. Is the battery charging? It says more than 10 hours. That's weird. Why is it showing the CPU temperature is 53 Celsius? Oh yeah, the CPU's cooled down now. It was just getting hot when it was starting. Seems okay. Alright, well, I'll go ahead and call a close to this video. It looks like this board is repaired. We're gonna do some more. We're gonna do some more testing just to make sure everything is functioning, like the camera, Wi-Fi, and everything. But we'll call this one fixed. So anyway, thank you for watching, and I hope you have a good day. We'll see you in the next video. Bye now.